In this video, you will learn about the experiment number 7. The objective of this experiment is to understand the motion of a falling object in a viscous fluid and also to estimate the viscosity. An object falling in a viscous fluid feels a viscous force. If the object is a sphere, the formula for a viscous force is right here. Eta is the viscosity, r is the radius of the sphere, v is the speed of the sphere. This force is point in the opposite direction of the velocity. Falling objects in fluid near the surface feel three forces. One is the gravitational force, one is buoyancy force, the other one is the viscous force. The sum of viscous force and the buoyancy force is pointing up. The gravitational force is pointing down. Eventually, the object will fall at constant velocity. Therefore, the net force is zero, and we can write the sum of two forces that point up must share the same magnitude of the force that points down, which is the gravitational force. We can use this equation to find this constant velocity, which is also called the terminal velocity, right here. With this formula, if we know the terminal velocity, we know the radius of the sphere, we know the acceleration by gravity, we know the density of the object and also the density of the fluid. We can find the viscosity. This experiment, we will find this number. Next, we will see how we do this experiment. Step 1. We will measure the diameter of all spheres. Step 2. We will measure the mass of each sphere by using a digital balance. With these two quantities, we can derive the density of the object. To know the density of the fluid, we will use hydrometer. We will read the density at the surface of the fluid. The density is equal to the observed number on the scale times the density of the water, which is 1000 kg per cubic meter. Step 4. We will use a thermometer to measure the temperature of the fluid, shown in this figure. Step 5. We record the type of the liquid as glycerin. Step 6. We will calculate the square of the diameter of all spheres and record them all. Step 7. We will set up the distance by using one rubber band at the beginning position and the other band at the end position. See the video. Step 8. Drop a sphere at a time. Once it passes the first band, start the stopwatch. Once it passes the second band, end the stopwatch. Record the time. See the video. Step 9. Calculate the average time for each sphere. Then you will use the distance s and the time you have from step 9 to calculate the terminal velocity for each sphere by using this formula s over t. And then you will plot this terminal velocity versus d squared. Use d squared on the x-axis and use terminal velocity on the y-axis, and then plot your data. And then you will draw a trend line and find the slope of this line, which is delta y over delta x. Next, you will calculate the viscosity by using the following equation. You know the density of the object, the density of the fluid. This is the acceleration by gravity over 18 times the slope. This thing will give you viscosity. And then you will compare the viscosity from the experiment and the one from the graph from your book, and then calculate the percentage error. You must show how to get the velocity, the slope, and the viscosity. Finally, you will give some discussions and the conclusion. Thank you.